Okay, in this video we're going to balance this equation using, assuming that it's a basic equation, or assuming that it's in a basic solution. Again, we're going to try it first by identifying our objects that have oxidation number changes. This is an element, and it goes to, this is -6, and it goes in compound, so it's going to have a change in oxidation number. The oxygen in this compound, there are 3 of them at -2 each. The total for this compound is -2 from its charge. It's x, so x equals -6, or x minus 6 equals -2, or x equals 4. So here it's +4. So we go from 0 to +4. On the other hand, here, nitrogen starts at, this is 3 times -2, and it's got a total to -1. So the nitrogen in this compound, x minus 6 equals -1, so x equals 5. So nitrogen starts at a charge of +5. Here it's going to go to something else. Let's just look at this. This is 4 times -2, and this has a charge of 0. So these N2s must have a total charge of 8. That's the charge for N2 as a combination of atoms. That means each nitrogen would be +4. But since we need to have 2 of them in the final compound when this thing is balanced anyways, we might as well leave it together with its total charge together. In that way we won't end up having to multiply the whole equation by 2 or anything silly like that. So if I have N2 down here, that means I need 2 nitrogens in this half reaction, which means the total charge I'm dealing with here is actually +10, +5 from each one of those nitrogens. So I go from +10 to +8. That must mean that 2 electrons are absorbed. And alternatively, I go to 0 from +4, and that will emit 4 electrons. Here, if I go +4 -4, I can see I get 0. Here, if I go +10 -2, I get to my +8. So those are my 2 half reactions. They sort of ran into each other there, so I'm just going to clean that up a little bit. There, we can see those better now. So 4 electrons are produced when only 2 are used up, so I'm going to have to multiply this equation by 2 to get the electron balance correct. Now I have 4 electrons used up, which matches my other 4. That becomes a 4, and that gets a coefficient of 2. Now transferring those coefficients up to the original equation, that means that, I don't know what happened there. Sorry about that. That means that each of these, I think that's tellurium, get 1s, and the nitrogens, this nitrogen has a 4, and that's from this 4 right here, and this nitrogen has a 2. That's from this nitrogen right here. Okay, now I need to balance the oxygens and hydrogens and all that stuff. So what I'm going to do is I'm going to erase all this stuff that was done to balance the charge, and then I can focus on the second half of this problem. So with my 1:4:1:2 ratio that we see in the coefficients here, I've made sure that the number of electrons used and the number of electrons produced is the same. So now I can focus on oxygen. I have 8 in this compound, 3 here, for a total of 11 on this side. I have 12 oxygens in the nitrogen compound on this side, the nitrate, and that's all I have to work with there. That means that I'm just missing 1 oxygen on this side, so 1 H2O. Putting that H2O in, I've introduced some hydrogen that's unaccounted for. So there's only 2 hydrogens there, so I have to put 2 hydrogen ions on this side. And now it's balanced if it was in an acid. So to take it from here and to balance it in a basic solution, what we have to do is we have to get rid of these hydrogen ions. The way we want to do it is we want to imagine reacting them with hydroxide ions, and then when a hydrogen ion and a hydroxide ion react, they produce water. So imagine I had 2 hydroxides here. And just like in math, whatever I do to one side of the equation, I want to do to the other side of the equation. So if I added 2 here, and then I have to add 2 over here as well. These two hydrogen ions and hydroxide ions will react to form 2 waters. What happened there? There we go. So those 2 waters are produced on this side, and that uses up all of those guys. When I produce 2 waters over here, now I have water on both sides of my equation. It's redundant. So if I imagine taking away a water from both sides of the equation, that would take away that water, and those 2 would go away. And then if I took away a water over here, then 2 minus 1 H2Os would just work out into 1 H2O plus my TE. So I'm just writing out the overall reaction here, simplified with the waters gone that canceled out and just the hydroxides. And what I see is, now I can just check my charge to see if I got that all right. Here I have a -4 charge just from the nitrates. Here I have -2 from the tellurium oxide, and 2 from these hydroxide groups. So that's going to get me a -4, and here my -4 equals my -4, and so I can see that I've balanced this equation correctly.